Okay, hi everyone. So yeah, I'm obviously not at school today. You have a supply teacher, but that doesn't mean that we still can't do the lesson that we were going to do anyways. Just keep up with what the other math classes are doing. Okay. So yesterday we talked about the law of sines. Today we're going to be talking about the law of cosines. Okay, and what this is, it's just like the more complete version of the Pythagorean theorem. Okay. So with the Pythagorean theorem, that's used for right-angled triangles. The law of cosines can be used for any triangle. Okay, just like the law of sines can be used for any triangle. It doesn't have to be a right-angled triangle. So can the law of cosines. Okay. So for any triangle that's ABC, like the one here, when we have the law of sines, we would know two of the same letter. So we would know either angle B and little b, or angle A and little a, or angle C and little c. Okay. But say if we knew angle B and we knew angle A, or side length A and we knew side length B, we wouldn't be able to find uh, anything using the sine law because we need to know angle B and little b. Okay. Or maybe we know angle A, we know side B, and we know side C, but we don't know anything else. So what we use is the cosine law for this. Okay. So what the cosine law looks like, we're going to do three different versions for every unknown variable, but it's really the same law, just we're just switching up the letters depending on which angle or which side we're looking at. Okay. So to find side A, it would be a squared is equal to b squared plus c squared minus 2bc cosine of angle A. Okay, so we know B, we know C, and we know A. So we can use this formula to find out what A is. We just have to take the square root of both sides. Okay, and if you notice, this part right here is actually looks like the Pythagorean theorem, right? Except that c squared equals a squared plus b squared, which we'll get to in a minute. But it just has this extended bit here. Okay, and what happens when you have the cosine of 90 degrees, so right angle triangle, cosine of 90 is 0. So you get rid of all of this and you're just left with a squared equals b squared plus c squared. So that's why it looks like the Pythagorean theorem, but it's not really the Pythagorean theorem. Okay. And you can also rearrange this to solve for the angle. Okay. Oh, here we go. So just look at cosine A for a minute. So we have cosine A is equal to b squared plus c squared minus a squared all over 2bc. So what we did was we switched these two. Okay. So we'd have b squared plus c squared, bring the a squared over, it becomes negative a squared. Okay. And this will become positive on this side. And then we divide both sides by 2bc. So those will cancel out and we're just left with 2bc. Now, the reason we have a squared, b squared, and c squared all equal to different ones, they're all the same formula, just depending on which angle we're looking at or which side we're looking at. So if we're looking for side B and we know A and C, it's the same formula, except we're just switching out A with B. They just switch spots. So wherever we had A, we have B, and wherever we had B, here and here, we have A now. Okay, and the angle changes as well. Okay, so A squared equals B squared plus C squared minus 2bc cosine of A. Or b squared equals a squared plus c squared minus 2ac cosine of b. So we switch the two a's, a with b and b, and we switch b and b with a and a. Okay. For c squared, there also may be an error on your sheet. No, it's just on the answer sheet key. Okay, perfect. Never mind. Okay. So same thing with c squared. We have c squared equals a squared plus b squared minus 2bc cosine of c. Or cosine c equals a squared plus b squared minus c squared all over 2ab. So really, these six formulas that we have here, they're all the same formula, just we're switching the letters based on what the angle we're looking at, and these two are just rearranged from one another. Okay? So you will need to memorize the cosine law, but the good news is you can just pick one of them. So if you just pick a squared equals b squared plus c squared minus 2bc all over or times cosine a, you can use this formula and you can rearrange it, or you can memorize both of them without having to rearrange it. And when you find the angle, just make sure you take the inverse cosine once you get this down to one number. Okay, but don't worry. We will do some examples together, okay? So again, the Pythagorean theorem is just kind of like an abbreviated form of the cosine law, just because we have a cosine of 90-degree angle is 0. So that last term here becomes 0, and we're just left with c squared equals b squared, a squared plus b squared. Okay? So let's do some examples. So we want to find n, okay, the one that's bolded. So let's go like we were doing yesterday. We have our sides and we have our angles. So our sides, n is little n is across from capital N. So this is big M here. That's our M. So that must be our O across or opposite there. Okay. So M is equal to 39 meters. Oh, sorry. These are sides that are lowercase. Lowercase m is 39. N, we don't know, but we're going to find out. And little o is 14 meters. Our angles, capital M, we don't know, but really we don't care in this example because all we're looking for is lowercase n. Capital N is 55 degrees. And capital O, also don't know, but we also don't care. Okay, so what we're going to use is n. So instead of A, B, or C, we're going to use N, M, and O. Okay, so you put the side that you want, N squared equals the other two, M squared plus O squared plus, or sorry, minus those two again. Minus 2 MO times the cosine of the original one that we were looking for, or the letter that we're looking for, cosine of n. Okay, so of n squared equals, so m is 39 squared plus 14 squared minus 2 times 39 times 14 cosine of 55. Okay, so n squared. My calculator's not handy. Oh, so I should have been better prepared. 39 squared equals. So if you want to do this all in your calculator at once, you can. I'll do it step by step for those who need it. Okay, 1521, 14 squared, 196 minus. Okay, if you type this all into your calculator, it'll go as once. So 2 times 39 times 14 times the cosine of 55 is 626.35. Okay, add all these together, plus 6 minus 6.5 equals, so n squared equals 1,900 or 1,090.655. Now, we're not done because we still have the squared on our end. So get rid of that, take the square root of this number, and we get n equals 33.0, you'll leave that 0 meters. Okay, and that's our final answer. Okay, so the variable that you're looking for here, the other two go here. They're all squared, minus the two that you're not looking for, cosine of the one that we are looking for. Okay, just the angle of it. Okay, if you need to pause, if I went too fast and people need to copy down, feel free to pause at any time, really. But I'm going to move on to the next one. Okay, so here, now we're looking for angle E. Okay? So we have our angles D equals E equals, oh, nothing this is labeled, but we can call it F. F equals. Okay? And what we know instead are all of the sides. We don't know any of these angles. Okay? So if you don't have any angles, but you're looking for an angle, this is when we have to use the other form of the quadratic, or not the quadratic, sorry. Too many formulas. The cosine law. Okay? So we have three sides that we know. We have little d across from D, which is 4.7 centimeters. We have little e, which is across from E, 7.1 centimeters. So it must mean little f is 9.6 centimeters. Okay? So the formula that we're going to use for this, typically I like to write it out myself again. So E squared equals D squared plus F squared minus 2df cosine of E. Just because it helps me rearrange it easier. If you just want to memorize the other way, go right ahead, whatever is easiest for you. So we have cosine of E equals D squared plus F squared minus E squared all over, that's a squared, all over 2df. Okay, so again, it's not with A, B, and C, but those letters don't matter. What matters is that we have capital E across from lowercase e, capital F across from lowercase f, capital D across from lowercase d. Doesn't matter what the letters are, as long as you set them up right. Okay, so here we have the angle that we're looking for, E. The two other sides, squared minus the angle, the letter that we're looking for, all divided by 2 times the 2 that we're not looking for. Okay? So we have 4.7 squared plus 9.6 squared minus 7.1 squared all over 2 times 4.7 times 9.6 equals cosine of E. Cosine of E. Punch that into your calculator. Remember, these are all hypothetically in brackets. So if you do it into your calculator, just put brackets around the numerator and the denominator, just so that it doesn't divide something too quickly. Okay. If you do that, you'll get 63.84 divided by 90.24. Okay. Put that down. Divided by 90.24. Cosine of E equals 0.7074. And then to get rid of the cosine, we do the inverse cosine on the opposite side. 0.74. So E to the nearest degree is 45 degrees. Why did that happen? Stop doing that. Okay, so E will be 45 degrees. I know it doesn't really look like it in that picture, but remember, they're not to scale all the time, okay? Sometimes we'll try, but it doesn't always work out perfectly. If it's not to scale, that's okay. Okay? Again, pause if you need to copy it down. But let's move on so that this process is faster for me. Okay, so here we have triangle ABC, and we get the three side lengths, okay? Triangle. Again, not to scale. A, B, C. So that means this will be a little a, this will be a little c, and this will be a little b. Okay, so A equals 11.2 centimeters. B equals 23.4 centimeters. And C up here was 17.8 centimeters. Okay, so we have three sides. And we have to solve for all of them because we want to solve the triangle. So what you do when you solve the triangle and you have all the angles that you're looking for, or looking for all the angles, find the largest one first, just because it's the easiest, and then everything else after that will work with the sine law, okay? So, therefore, we are going to use first cosine of C, sorry, not C. The biggest angle will be the angle across from the biggest side. So 17.8 centimeters, 11.2 centimeters, 23.4. B will be the biggest side. So cosine of B will be equal to A squared plus, sorry, when I was in university, we always did it based on C. So I kind of default to that. B squared minus, oh my God, I just did it again. Your supply teacher thinks I'm a moron right now. B squared all over 2AC. Okay. So cosine of B would be equal to 11.2 squared plus 17.8 squared minus 23.4 squared all over 2 times 11.2 times 17.8. That is an 8, believe it or not. Cosine of B equals negative 0.105.28 all over 398.72. Okay, is it okay if we get negative there? Yes. Cosine doesn't care if you have like a negative decimal. It has positive and negative numbers. Okay, you'll learn more about that in functions next year. Let me see the sine curve. Okay, so cosine of B, 5.28 by 398.72 equals negative 0.2640. B is the inverse cosine of that. B is equal to 105 degrees. Okay. And now we can use sine law. Okay. So let's just find angle A. We'll go alphabetically now. So remember, if we're looking for A, for the sine law, we do sine A over A because we're looking for the angle. And now we know both sides, or both of B's, we have sine B all over B. So we have sine A is equal to, or over 11.2 is equal to sine of 105 divided by 23.4. Okay. Let's put this down to a number. I'm going to skip some steps here because I've been talking all day and my throat is kind of starting to hurt. Why did you do that? 11.2 equals 0.04127. We're going to multiply that by the 11.2. 0.4623. A equals the inverse sine of that. 23. A equals okay, so I left some extra digits in my calculator. So right now I'm getting 28 degrees. But if you're doing it and you're working through, because it's 27.5, if you get 27 degrees, like 27.3 and round down, that's fine. As long as you're within a degree, you'll be good. Okay, so now we have A and B. If you want to use sine law to find C, you can, but I wanted red. Much easier way would be C equals 180 minus A minus B. C equals 180 minus 28 minus 105. So, shut it out. C equals 47 degrees. And we are finito. Okay, so solving triangles can take a little bit of time just because you have to do a lot of steps. So here we use the cosine law, we use the sine law, and then internal angles. Okay. Typically like this one because it uses both of the laws together. So just something to keep in mind for your test and quiz on Friday. Okay, last one. A word problem now. A boat is sailing north through a narrow strait. Through one particular narrow section, the lighthouse marks the western shoreline, while a buoy indicates a rock hazard directly beneath it, east of the lighthouse shown. What's the width of the strait to the nearest tenth of a kilometer? Okay, so we are looking for the width here between the lighthouse and the rock. Okay, so we'll call this R, we'll call this L, and if we're calling this W, this will be angle capital W. Okay, so this will be little r, and this will be lowercase l for lighthouse and rock. Okay, so we don't have to do the same. We know what r is, we know what l is, but we don't, and we know what capital W is, but we don't know what lowercase w is, and that's what we're looking for. So we can use W equals r squared plus l squared minus 2rl, like R.L. Stein, cosine capital W. Okay? Again, the letters don't matter. You could have called this A, B, and C if you want. Just as long as you know what your width is going to be, the letters don't matter. What matters is you put everything into the right spots. And really, with cosine law, you don't have many other options besides what we're going to do right here. Minus 2, 4.2, 4.5, cosine of 26 degrees. Really, we need to use cosine law here, and all you have are two lengths and one angle. So the two lengths have to go here and here and here and here, and the one angle has to go here. You don't have any other options. Okay? I'm sorry, this is W squared. So W squared, you simplify all that, 20.9028. Take the square root to isolate W. the width of the straight is approximately equal to 4.6 kilometers. Okay. So that's everything for today. There's also a worksheet for everyone. So if you want to work on the worksheet, now you should have some time. If you have to go back and pause any part of the video, go ahead and do that. If you missed anything, all the answers are available. I'll make them available on the NCBLE. Sure, we'll keep it right now. All the answers are available on the NCBLE. And yeah, we'll take up any questions that you have tomorrow. We'll take them up. Okay. So if this was a lot, don't worry about it. Just try your best on the worksheet. Practice questions, and if you have any questions, save them for tomorrow. We'll go over them first thing. Okay. Other than that, hope you're all having a great day, and we'll see you on Thursday.